Welcome to Spring LIB.
Hello, we have a question which is related to the vertical swing. It is given that 0.4 kg mass is okay, 0.4 kg mass. So let us assume mass to be m equal to 0.4 kg mass and tied to the end of a swing, okay, hung from ceiling. So let us hang it from the ceiling, and it is okay, and it is then swung in a horizontal circle, causing a string to create a cone shape. Okay, the angle between the string and the vertical. So first of all, this is the vertical. So this will be the angle theta, and this will be the vertical axis. So the cone will look like this, like this, and this should be the radius of the cone r. It should be vertical, remember. Okay, so now theta is being given as 24 degrees. We need to find the tension in the string and vertical velocity and rotational frequency. What is the velocity and the rotational frequency of the mass? Let us see what else is being given. Nothing else is being given. So let us just analyze the forces. So if we suppose the mass is here, so let us draw the forces. Here it will be mg vertical downward. If this is theta, okay, so this will be the tension. If this is theta, this has to be angle theta, because this is parallel to the vertical, and this will be the alternate angle. So this component of the tension will be t cos theta, and again this will be the component, because we are resolving tension in the rectangular components. So this will be t sine theta. So let us assume this to be x-axis, this to be y-axis. So let us just write. Okay, so let us use Newton's law in vertical and as well as in horizontal direction. So in x direction, that is horizontal direction, forces. Okay, now we have this in horizontal direction. There is only one force, t sine theta. Okay, so t sine theta should be equal to the centripetal force, that is mv square by r. Okay, so t sine theta should be equal to mv square by r, where r is the radius. Okay, so this is equation number one. And in vertical direction, we should say there is only two forces which will be balancing each other. So t cos theta equal to mg. So T will be equal to mg by cos theta. So from here we can find the tension out. So tension will be T cos theta. So tension will be, let us plug in the values, 0.4 kg into 9.8 meter per second square divided by cos 24 degrees. Okay, so this is zero point 0.4 into 9.8 divided by cos 24 degrees, that is 4.29 newtons. So this is the tension in the string. Okay, now we have to find the velocity. So from equation number one, t equal to mv square by r sine theta. So V square will be equal to TR sine theta by M. Okay, so V will be equal to TR sine theta by M under the square root. Okay, so we have everything except this R, that is radius of the cone. Okay, so let us plug in the values whatever we know. V equal to, the tension is 4.29 Newton, radius we don't know, and this is R sine theta. Sine theta is sine 24 degree divided by M, that is the mass, 0.4 kg. Okay, so into sine 24 degree divided by 0.4 and under the square root 2.01. So 2.01 under root r, this should be the velocity. This should be the velocity of the mass, meter per second. Okay, now we have to find angular frequency or the frequency. So we know that frequency is always 2 pi by omega. Okay, wait. So this is omega by 2 pi. Omega by 2 pi. Now we have V equal to R omega. So we should write here omega equal to V by R. So frequency will become V by 2 pi R. So let us plug in the value of V. So V will be 2.01 R raised to the power 1 by 2 by 2 pi R. So this will be equal to, okay, 0.332 divided by under root R hertz. So this is the rotational frequency. Okay, and let us check if by any mean we can calculate the value. So we are not being given the length of the string, so we cannot calculate R. So answers will be in terms of R only. Thank you so much.